The Sensor Grid for ENV project brought together this new linked data and web technology data in order to try to allow people to find and machines to find all this environmental data. So as an example, if you were a human, you could probably find lots of weather data on the web by searching in certain places with certain keywords. A computer would find that very difficult to do at the moment with the web, and so it has to have specialized techniques to go into these data repositories, know what is in them, and actually work out how to extract the information. So when we as humans Google for information such as the Southampton weather, we process all the text we see on the pages that we're retrieving, and we very quickly sift through the information to choose the bits that we're interested in. A computer can't do that. It can't really understand which parts of the web page are to do with the temperature and winds and so on. And so you have to actually construct specialized software to allow the computers the same kind of access to all this data on the web that we have. So in the Sensor Grid for ENV project, what happens is each source of information, for example, a buoy floating on a sea generates many streams of information, is wrapped up in a description so that a computer can understand that description. Now this sounds counterintuitive, but you can imagine that if enough people describe, for example, wave height in a similar way around the world, then you can solve this problem in that all data to do with wave height would have the same kind of information alongside it, describing it. Now this has been done for many years in other ways, for example just by standardizing the metadata that you would describe things with, but there is a human problem that it's impossible to get everybody in the world to describe temperature as, for example, temperature, even the units would be centigrade or Fahrenheit. So rather than attempt to force everybody to agree on a standard of metadata, the semantic web actually uses common groups of descriptions. So it's possible for one entire country to use a description of something like rainfall and describe in another country with something like precipitation. As long as you say that this concept precipitation means the same as the other concepts rainfall, then you can actually unify all the data that those two describe. So the semantic web technology used in the project uses things called ontologies. These are supposed to be fairly fixed groups of concepts in a certain domain. So in the area of meteorological forecasting, it would encompass all the types of things that you'd imagine that that domain needed to describe its data and its processes. So in the Sensor Grid for ENV project, what happens is we have chosen specific ontologies which are fairly commonly used, have come from various parts of the world, and are sufficient to describe all the data that we're integrating. Once data has been semantically marked up in this way, computers can actually go out and find information, so it would be much faster to allow computers to go and gather all meteorological data covering a huge area of the globe than to have a team of people surfing the web, downloading files, converting file formats and so on, which is how you might imagine quite a lot of data is gathered at the moment. So this data integration allows people to do much more powerful things, possibly automatically. So if a computer can reason about the information, it can also eventually make more decisions about if I can't get this data, then maybe that data is good enough for me. So for example, there may be some decisions that the computer can make about the kind of data that are useful for the end user. So one of the emerging technologies which is leading to an extra boost to environmental data is wireless sensor networks. So these are composed of very small, cheap electronics systems. They have about the same computing power as something from a 1970s home computer, but they can be produced in larger numbers, and they have slightly more intelligence. So rather than just logging data, they can make decisions about the data, and they can intercommunicate between themselves, for example, to make sure that the data gets out. So in the project we've actually been experimenting with how these systems can integrate into the whole information infrastructure of the Sensor Grid for ENV project. So to test whether all this technical theory is actually usable, the project has put together a registry which uses the semantic description of data sources so that computers can find them, And then we've carried out an experiment using all the ocean data from the south coast of the UK as a test set of data for the system to see whether you really can find those data sources, integrate them, and then show them to particular users for particular things that they actually want to do. So we're testing the theory against users' expectations of a modern web technology. So in ECS we've been exploring something that you may have seen in other parts of the web called mashups. So this is where, if you have open linked data, you can construct new views on the data. So for example, it's easy enough for us to use the same environment data that might be used for hazard prediction in order to show if it's a good time to go surfing due to the wave heights. That kind of thing can be put together very easily these days using modern web technologies. So with the various technical aspects of a project like this, it's quite easy to imagine developments in each individual case. But what we've achieved in SensorGrid for ENV is to actually implement many of these new technologies in a real working system using real data for real users. And so it's been a two-way learning process, an exchange between the technical teams from the computer science point of view, for example, and the environmental data scientists.